All right, y'all, we're going to continue our talk of bonding. We're going to do a quick review of ionic bonding. And remember, an ionic bond involves a transfer of electrons. It's very important to understand that it's a transfer of electrons from a metal to a non-metal. Okay, and remember, the metal is called a cation, and it makes positive ions in that transfer because it gives away electrons. And the non-metal is the thing that receives the electrons, and so it becomes a negative ion called an anion. So if I'm transferring this pen, one person's giving it up, the other is taking it. So it's actually creating positive, full-on positive charges and full-on negative charges, and that interaction is called an ionic bond. Now, it's going to make compounds with formula units, we call those subscripts, that make it so the total charge of the compound has to equal 0. And so because the total charge of the compound has to equal 0, there's only one way to write it, and we call that the law of definite proportions, because there's only one way to write an ionic compound. And the example that I gave here is if you have a copper that has a +2 charge and a fluorine that has a -1 charge, then you're going to need 2 fluorines to cancel out 1 copper, and so the total compound is going to be CuF2, which is copper 2 fluoride is the name of it, and the total charges cancel out because you have a total of a -2 on this side and a total of a +2 on this side. And so that is going to be ionic compounds. And now I will tell you that ionic compounds tend to make solids when they make compounds. Now, moving on, we have covalent molecules, and this is the new stuff that we're doing, and it involves sharing electrons. So that is totally different than transferring electrons. And the reason why covalent molecules are going to share is because they want to get a full octet of electrons, which means they want 8 in their outer shell, just like a noble gas. And so because they can share to do that, you're going to see in a minute they're going to create different types of covalent bonds. Now, covalent bonds are always going to be between 2 nonmetals, or more than 2 nonmetals, but it's always going to be between nonmetals. And just as a reminder, the nonmetals are to the right of the staircase, and hydrogen. Remember, don't forget about hydrogen's over here, and it's a nonmetal also, but everything else is to the right of the staircase. Now, when these atoms form covalent bonds, they're going to share pairs of electrons. So, fluorine has 7 valence electrons. Chlorine has 7 valence electrons. So, basically, they're sharing this pair right here of electrons, and when they do that, now chlorine has 8 in its interaction, fluorine has 8 in its interaction, and they're happy. So a single covalent bond is when they share 1 pair of electrons. So that's what it looks like with the electrons. When you write it out, you're just going to draw a stick to represent that shared pair of electrons. So when you write out the structural formula, you have the F with the lone pairs of electrons, we'll get into that later, around it. Okay, and then you've got the stick showing they're sharing 1 pair of electrons. Now, if they share 2 pairs of electrons, that is called a double bond. And in a double bond, they're going to share 1 here, and they're going to share another pair. Okay? Sometimes you'll hear the word pi bond. It's also called a pi bond. In a single bond, it's also called a sigma bond. But we're not going to test you on that, so you don't have to worry about that. But when you get to college, remember that a sigma and sigma are the same. Single and sigma are the same. Double and pi are the same. So this is when you share 2 pairs of electrons. So if you look here, oxygen has 6 valence electrons. Sulfur has 6 valence electrons. If it shares 2 pairs, now it has 2, 4, 6, 8. And oxygen has 2, 4, 6, 8. So it's sharing 2 pairs of electrons to get a full octet. A triple bond is when they share 3 pairs of electrons. So now this nitrogen has 5, this phosphorus has 5. Well, if it shares 1 pair there, shares another pair there, shares another pair there, that's 2, 4, 6, plus that is 8 for phosphorus, and then 2, 4, 6 plus that pair there is 8 for nitrogen. And so a triple bond is going to have 3 sticks represented. A double bond will have 2 sticks, and a single bond will have 1 stick represented. Now, it's important to understand that when you're talking about these interactions, a single bond is the longest bond, but it's the weakest bond. The double bond is a middle length, middle strength, and a triple bond is the shortest bond, but it's also the strongest. And so I think of that like I take a pencil, okay, and if I have a lone pencil, it's long, but it's weak. I can break it in half. And then I have a middle length, middle strength, and I can break that in half. It's really hard, but okay. And now I've got the smallest, so I've got 3 small pencils, and that's really hard to break because it's really, really strong. So that's a triple bond is the shortest but strongest. The double bond was middle length, middle strength, and a single bond was the longest but weakest. All right, go ahead and stop.